So the canaliculi are essential for the osteocytes to survive because the canaliculi allow for connections between the plasma membrane of one osteocyte and the next one. And all the osteocytes are thus connected to each other through the canaliculi. And then critically important, they're connected to their blood supply that is in the very center of the osteon. So the blood supply enters into the bone, blood and blood vessels migrate through the osteons, and through connections of the individual osteocytes, ultimately through the blood supply in the central canal, they're able to remain alive even though they're encased in solid bone. So diffusion of nutrients and wastes, again, through the canaliculi, ultimately through the blood supply, blood vessels in what's called the central canal. Here's just another view to highlight the fact that in yellow are the osteocytes, and they have plasma membrane connections between each other through the solid bone matrix, through the canals, the little gaps, tunnels between the solid bone matrix, which are called canaliculi. And then this empty space here would be filled by the blood vessels in the central canal. Osteoblasts are bone cells that are building bone material, such as we see here. So here's an osteoblast. It secretes extracellular matrix, which is referred to as osteoid, which is soft, rubbery, like cartilage. And when that gets infused with calcium salts, that becomes new solid bone. So the osteoblasts, B for building bone, right? And they are abundant in the inner and outer surface of bone, because that's where they will build new bone as needed for growth of the individual and for bone repair, like due to a bone fracture. They produce this matrix. It becomes new bone. That process is called osteogenesis, and that's the calcification of the matrix or mineralization of the matrix with those calcium salts to make it a solid bone material. If the osteocyte gets enveloped and surrounded by the bone matrix, it will differentiate. It will become a mature bone cell called an osteocyte. Oh, just a picture I found of osteoid being secreted by osteoblasts. All you can see is their nuclei. Then the osteoid would become calcified, encasing the osteoblasts, and they would differentiate into osteocytes. Where is that word? Here you go, osteocytes. There are stem cells within bone called osteoprogenitor cells. And here we go. Based on bone needs or stresses, they can differentiate into osteoblasts that can build new bone material, and if they get encased in bone, they become osteocytes. And they are essential in bone repair because if there's a fracture, the osteoprogenitor cells receive the signal to become osteoblasts to build bone, to do bone repair, as needed. So your osteoprogenitor cell, it's a stem cell, can differentiate into the osteoblast, which builds new bone. If it gets encased in bone, it becomes an osteocyte, and those are the elongated plasma membrane extensions that tunnel through, well, they're not, are found within the canaliculi that connect adjoining osteocytes. There are bone cells that dissolve bone. These are called osteoclasts. They do what's called bone resorption, by dissolving solid matrix by secreting enzymes and acid, like hydrochloric acid, to help dissolve away bone. That might not sound like a good idea, But if your blood calcium levels drop, the osteoclasts will start dissolving bone to release solid calcium in an ion solution, calcium ion, which can resupply the blood as needed. And also they are important in what's called bone remodeling. Bones change their shapes as we grow in size, and bone remodeling is accomplished by osteoclast and osteoblast activity. So they secrete acids and enzymes which dissolve the solid bone matrix, and that process is referred to as osteolysis. And again, important in bone remodeling, along with the action of the osteoblasts. Just a picture I found of the multinucleate osteoclasts. So they're kind of a unique cell, fairly large, and they will resorb solid bone matrix. Oh, just another picture I found. I'm amazed that they were able to take this picture, but that's a osteoclast, and this is the groove that it has dissolved away in solid bone matrix. Okay, let's compare and contrast compact bone and spongy bone. Compact bone is solid in appearance and very strong, and spongy bone is kind of porous, open in appearance, still relatively strong, but it is not soft like an actual sponge. It's only called spongy bone because it has these gaps and cavities within it, and superficially it looks kind of like a sponge. So compact bone is dense and solid, and it forms the walls of bones, essentially on the external surface. On the ends of long bones, the compact bone might be fairly thin, and it's thicker along the shaft, or what's called the diaphysis of a long bone. So the compact bone there serves its purpose of resisting compression forces. So spongy bone has this open network of struts that are referred to as trabeculae. There's the term. The material, the matrix of trabeculae, is identical to that of compact bone. It's just that the way that the matrix is organized is different than it is in compact bone. Compact bone has these cylindrical type structures called osteons, and they are absent in spongy bone. So here's a view of a joint. One bone that is joining, articulating with another bone, and internally, in the end of a long bone, you have an abundant amount of spongy bone, but covering the outer surface, you can see it's a fairly thin sheet, but that is compact bone. And when there's more stress forces applied to the bone responds by making thicker walls of compact bone, like we see here. But there's spongy bone there in the center of this particular bone. So spongy bone, it's deep within the bone, surrounding the space called the marrow cavity, if a bone has a marrow cavity, and most long bones do. So spongy bone is found in the enlarged ends of bones. We'll find out that those are called epiphyses. But also there's at least some along the inner wall of the compact bone in the area referred to as the medullary cavity. That's normally filled with at least some yellow bone marrow. And that yellow, the bone marrow cavity, it's a loose connective tissue with abundant adipose cells, adipocytes, fat energy stored in cells within the long portion of the bone referred to as the shaft. And then the red marrow, as we mentioned earlier, that is the region of spongy bone that's found in the elongated ends of the bones, the epiphyses. So that's an epiphysis, that's another epiphysis, plural is epiphyses, and within the gaps and spaces of the trabeculae of spongy bone are the stem cells for blood cell formation. And that's why this part of bone, spongy bone, is referred to as red bone marrow. Oh, just a picture I found of the trabeculae struts with osteocytes within their lacunae, and then these nuclei you see here, are the nuclei of blood stem cells of the red bone marrow for production of blood cells. We'll talk about this again when we do the blood and cardiovascular system chapters. Okay, some structural differences. I've mentioned them a little bit now. Compact bone, it has these elongated cylindrical structures that in cross-section look like tree rings. Those are called osteons or Haversian systems, and they provide a lot of compressional strength to bone. They have layers of bone matrix in concentric circles that run parallel to the axis of the bone. The osteons do. So that means, let's go back to this picture. The osteons are in this orientation in this bone, or in this orientation in this bone, because this bone is lying upright in a way. All right? So the osteons run in parallel direction to the long axis of a bone, long bone, that has compact bone. Let's see. The central canal with the blood supply, blood vessels within an osteon, is also called the Haversian canals. Blood vessels and the nerves, innervation, which we don't really see here, but there are nerves that are wandering throughout the central canals, in addition to the blood vessels. And connecting adjoining individual osteons, connecting them, essentially, because they all need a blood supply, are what are called perforating canals, also called Volkmann's canals. So they connect the central canals of adjacent osteons, ultimately to the blood supply that's coming into the bones. Concentric lamellae, think of concentric rings. Sorry, these are the concentric cylindrical lamellae, or sheets of bone surrounding the central canal that form the osteons, which are the structural functional units of compact bone. Interstitial lamellae, these are sheets of bone that are found between osteons, and we can see a little bit of them there and here and a little bit there. So they are basically remnants of osteons when the bones were younger and smaller. And then we also have what are called circumferential lamellae around the circumference. So on the outer edge of bone, we see here, these sheets go all the way around the bone. And those are the lamellae that are the circumferential lamellae of bone. They're not part of the osteons, and they are not interstitial lamellae. So three types of lamellae: concentric lamellae of osteons, interstitial lamellae between osteons, and on the outer edge of bone, circumferential lamellae. Just deep to the connective tissue periosteum that has a number of bone cells that we'll get to in a few minutes. So the periosteum covers the outer portion of the bone everywhere except where the bones articulate with other bones, and there they have the hyaline cartilage.